Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Suzanne Miller. I'm a principal researcher here in the SEI Software Solutions Division. Today, I'm very happy to work with two of my colleagues, Dr. Carol Woody and Robert Schiela from the CERT Division. And today, we're here to talk about something called Secure by Design, which is a discussion that we started with the director of CERT, Greg Tuhill, a little while ago. And we're going to continue that discussion today. For those of you that aren't familiar with Secure by Design, we are looking at key steps that organizations can use to integrate Secure by Design into their organizations. And we are going to be talking about what are some of the key principles of Secure by Design. So I want to welcome both of you. I also want to mention that this topic has been a key tenet of the 2023 White House cybersecurity strategy. And related to that, the director of CISA, C-I-S-A, the Cybersecurity and Infrastructure Security Agency. The director of that agency, Jen Easterly, recently visited our Carnegie Mellon University campus to meet with leaders to discuss Secure by Design and encourage tech companies in particular to incorporate these principles into their products. So this is a very big topic, and we're going to have a fun conversation about how do you do this if you want to make some of these changes as either a government agency or a corporation. How do you make this happen? So I want to welcome both of you to this podcast. And Bob, you've not been on our podcast series before, so I'm going to start with you to ask you to give us, our audience, a little bit about your background, why you came to the SEI, and sort of what's the coolest thing about your job at the SEI, and then we'll get Carol to do the same.
Sure, I'll try not to take the whole time, but I'll say it's a pleasure to be here for my first podcast, Susie. I have been at the SEI now almost 20 years, and I've been working in information security and cybersecurity my whole career. Trying to remember all the questions. So I'll just skip to what's great about my job, and it's easy to answer if I can have two. First, I'd say what both keeps me up at night and what gets me up and out of bed in the morning is the importance of our job and security. Technology has the potential of transforming our lives and being a great part of our lives, but it also has the potential of really hurting us when abused. And so trying to make sure that technology works as we want it to is what I find really exciting, as well as working with brilliant people. And I know it's cliche, but we have a few of brilliant people that are just really energizing to work with here at the SEI.
Excellent. And one of them sitting right next to you, Dr. Carol Woody.
I'm sitting with two of them today.
Oh, listen to you. Okay, all right.
You
can keep that coming. It's fine. Carol, tell us a little bit for those that haven't met you before.
I joined SEI actually almost 21 years ago.
And you were in one of my intro to software CMM classes way back early in your.
A lot of that.
Yeah, I remember that was my first time I met you.
Yeah, to get educated in a lot of what SEI was doing at the time. I came here to finish my PhD and to do a career shift because my background was in software and systems design and implementation. And actually strategic planning was where I ended up. And then coming into SEI, they wanted people to learn cybersecurity who had the background in development and engineering to begin to help figure out how to build things more securely.
Right.
So we've been really working in this space, although it wasn't labeled the same thing for quite a while. We've got a lot of pieces, but it's like the goalpost keeps moving out because the attackers get more sophisticated, technology gets more sophisticated, the uses get more sophisticated, and so I think that plays into why I find it interesting. It's an ongoing challenge, and I've always been one that loved problem solving. So believe me, we've got more than enough to go around here.
We do.
Keep me energized.
Well, and I appreciate, we recently had you speak about the acquisition security framework, so you've really been very active in all of these areas, and so definitely want to hear what you have to say today about secure by design. So let's get into that, and let's talk about, you introduced the idea, both of you, that the cyber landscape is really changing a lot, and there's things, everything from software-intensive, third-party components, supply chain, which I know, Carol, you're very involved in, DevSecOps, continuous authority to operate is very big in the DoD space. The shifts required to deal with these kinds of ways of looking at systems and these ways of operating systems, they really give us new considerations for establishing the meaning of secure by design. And that goes back to, Carol, your engineering approach. We have to bring this in engineering. It can't be, as we often talk about, it can't be bolted on at the end. So let's get an understanding of what does secured by design mean to you, so that we've got sort of that, because I could go, we did both some directions with Greg, but I want to make sure that we've got sort of a baseline of what is secure by design from your viewpoint, and what the SEI is doing with it.
Sure. So secure by design is a summary form, is largely performing more security and assurance activities earlier in the product and system lifecycle. So that means instead of waiting till we're testing the system, or it's already fielded and we're patching, or we're trying to apply controls in a system that's already been deployed, we're trying to do activities that try and ensure the security of the system earlier during the requirements phase, during the design phase, during the development activities, and doing more of those activities early rather than waiting till late. So that's generally secure by design at a high level. What I think has been changing as well is, first, what's not changing. So unfortunately, I think what's old is new for a lot of this. And what I mean by that is that, unfortunately, we're still suffering from a lot of the same type of security issues as we have for decades. And so a lot of the aspects that are causing the problems we've either known about or had been worried about for a long time. But what is new is the amount of interconnectedness of the systems today, the amount of automation that we're starting to apply to the systems today, and the amount of dependence on the system. And so that all leads to the risk is more than it has been, and the cost of trying to secure those systems during test and after deployment is just not sustainable.
Do you want to add anything to that, Carol?
Yes, I'd like to backtrack a little bit and have us think about the fact that most systems used to be composed heavily of hardware, and software was an incidental component. I've heard estimates it was less than 5% at times. At that point, if you didn't worry about software vulnerabilities and defects, you were really ignoring a very small risk. And we find that many programs, even today, still think of software as 100% reliable. But what's changed now is that software is now handling 99% of the functionality.
And the decision making.
And it's integrated across the infrastructure. It's integrated into the way the communications are handled. And so you have this system of systems of software, which means that now any vulnerability or defect suddenly becomes a lot more potentially visible. And we really don't have the mindset to recognize this risk early on and figure out how to mitigate it. So it's largely being ignored until we get to the implementation phase and the pen testers come in and basically prove that you've got Swiss cheese. Because you can slap all the controls on it you want to, but if the attackers can get around the controls very easily, they will, and certainly that makes the system less usable and less secure. We find so many developers and engineers still think that cybersecurity is an implementation problem. And yes, there are implementation issues, but we've got to take ownership in the engineering and development side for the pieces that lead to a lot of these problems.
So another recent podcast that we did was on a newer language called Rust. Mm-hmm. And what I'll assert is what you're talking about in terms of secure by design is making those kinds of decisions. What language am I actually going to implement in? Am I going to use a language that has some known, in this case, memory failure, kinds of Swiss cheese holes to it, or am I going to use a language that may not give me everything I want, but gives me more security? Those are design decisions. Those are not implementation decisions, because that decision has implications for performance and other aspects of things. So we're really talking about, as you say, really moving up to the left in the life cycle of where security needs to have a prominent role, not a second-class citizen role.
Well, the supply chain is a key element of that, too, because decisions about what cloud platform you're going to use, which development tools you're going to use, how you're going to integrate these pieces, how you're going to be applying them, when you're going to be applying vulnerability analysis tools, all of those are made very early in the life cycle. And if they are not well structured and well thought about based on the risk concerns that you need to have, and we find in many organizations they've never really thought about the threats that they're dealing with. They minimize them based on how it used to be as opposed to what it really is. All of those converge to create really major issues.
And something that I always talk about, Bob's not used to this, Carol is, we're dealing with legacy systems. I mean, part of that interconnected set of systems are legacy systems that were built and secured and tested and certified and deployed without really knowledge in many cases of these kinds of concerns and in these kinds of solutions. So in addition to secure by design on the new systems, there's this other aspect of secure by design, or at least evaluating what is the state of legacy software that we're dealing with, and how are we going to protect ourselves from the things that we didn't know, back in the 80s, because some of this software is that old, when you get into some of these cyber physical systems.
Well, it's that old, and it's a black box. We don't have the resources that are active now that really understand how to change it.
Right.
And many people are afraid to touch it because, if it ain't broke, don't fix it. But what does broken mean?
We don't know we don't know what vulnerable. And there are people, we know there are people in the threat space that will look at that black box and see it as a challenge. I'm going to open that up, and I'm going to, as an opportunity, I'm going to open that up, and I'm going to find out how to get at that, whatever that is. So our hesitance in that case can actually also be a fault in terms of our vulnerability.
And you really have to bring program management in. Mm-hmm. It's not just all an engineering problem, because how program management identifies risk is going to determine what gets addressed. And if risk is only looking at programmatics and cost and schedule and not considering the vulnerabilities and potential attack surface that you are creating, then you're not looking at the right problems that we need to have addressed.
And this especially goes for systems. We have a lot of systems now that we work with that don't just have a 5-year lifespan or even a 10-year lifespan. Some of these are designed to have a 50-year lifespan. And if it's designed for 50, we know we're going to push it out to 75 if we can get away with it. So when you have these very long time frames, the decisions that are made in year 1 or even year 5, have cascading effects way down the pike in terms of ability to make changes that we need to, because there's new threats, new technologies, et cetera, down the line.
Well, you're pointing out another aspect that needs to be thought about, because the requirements change over time. Mm-hmm. And the technologies through the supply chain and what the technologies can do change over time. But we don't have a really good way of making sure that the protections that we thought were there to begin with aren't deteriorating over time as the pieces are adjusted and changed. So it really boils back to integrating very effective risk management across the life cycle. And also thinking of it as a journey and not an activity. I don't do a risk assessment and then walk away and assume everything's fine because I've mitigated all those pieces. What I have to create is a way to manage and monitor over time.
So we're talking now, instead of talking about software sustainment, the language is shifting to continuous modernization, right? We had the Defense Innovation Board, software is never done, right? And this is another aspect of this. This is another dimension of it, right? That it's not only continuous modernization, but continuous cybersecurity evolution. Right. And we've got all of these things that we have to think about.
I think it is a change of mindset of what we even mean by a life cycle, because often when we think life cycle, we think of those 5 or 7 phases happening, right? That's basically traditionally from a waterfall model versus considering you have those phases, but you also have the time element and iteration those are happening, especially for very long lifetime or lifespan systems, happening over and over and over for a long time.
Adding on to that, you've also got a definition of ownership of the problem space that doesn't really fit with where we're seeing the challenges, because we talk about system owners, but does the system owner only own a small piece of the contents and components, or do they own where it sits in the system of systems and how it ties together? Too many of our engineering focuses are only inward within an arbitrary boundary and not really looking at what's the context that all of this is going to have to live in and survive in.
And some of that context is organizational. This goes back to the supply chain, right? My boundary is at the boundary of what my organization is responsible for, even though I may be very tightly interconnected to other system elements that are owned by other organizations and might benefit from some of the kinds of secure by design things going across interfaces. So this is, I think we've established in terms of the landscape, this is a huge issue. And it's something that I think, along with the acquisition security framework, to get more programmatic, especially, attention on this. This is really the engineering side of, we've got to up our game in the engineering requirements piece for looking at all these issues. And so you have, conveniently enough, at least 4 steps. I'm going to say at least because I think these are the initial 4 steps. I think this is going to grow. The number is not going to stay at 4. Sorry, people. But the 4 steps that if people have listened to this and go, oh my goodness, I got to do something about this. What are the 4 steps that they should be considering now to bring secure by design into their mental model and into their organization?
Well, they're really basic management steps, but they have to be performed at every level. You've got to have some level of planning, how you're going to scope what you're doing, where is your target. You can't just assume you'll get to some level of security magically. You've got to be really thinking about what can I support, and then how open can I make things as I move ahead. You've got to have the right tooling, because we're talking about a humongous interface activity and environment. And if you're not automating some of this, it's going to get lost, because we've seen with just vulnerability management, the volume is mammoth. Training is one of the key aspects. We're coming from a hardware-centric environment, so we've got to have all of the players at least have a basic understanding of this problem space and how to maneuver in it, or know when they have to get someone that adds more expertise. Too frequently we have budget constraints that are put in place that say, I'm hiring a rookie and they're just going to have to wander through and figure out how to make it happen, and the tools are going to help them. tools are to be used, but they can't run the process for you. And they're not designed to cover this full environment. They're still segmented as well. So we have to have a way of scoping how we deal with these. And then from there, we have to have a way of monitoring and measuring. It's going to be constant improvement. And if you're not preparing for this, because you can't solve the whole problem right away, then you're basically adding to the problem instead of supporting and helping address it.
And I want to go to the training one, because that's actually something that Greg and the director from CISA mentioned. I think it's training and education. This is sort of the same case as waterfall to agile. Until we really had the bulk of software engineers being educated in Agile, how to do it, in their undergrad curriculum, we really didn't see the push towards that in many, both government and commercial areas. And I think that idea that we've got to have this secure by design and the mental models associated with security embedded in our engineers, that's part of being a professional engineer and not just being a hack.
It should be, but the curriculum right now does not include any mention of that. We are actually seeing a few states stepping up to mandating that high school graduates have to have had at least one course. I know I've heard Nebraska.
Oh, okay.
No, excuse me, it's North Dakota and South Carolina, I know, have instituted mandates that their cybersecurity has got to be part of the high school curriculum for every graduate. So they will at least heard the word.
Yeah.
We can't say that about the current workforce right now.
Right.
And I think there's a big challenge to it. A word you used earlier was mindset and mental model, right? These are not, as you mentioned, not just simple training. Make some training, make it available, and they learn it, and that's all. It's not trivial, a trivial skill to get. It is a mindset change, which is going to be very, very significant of a challenge.
Well, it doesn't translate to checklists and templates.
Right.
And that's part of what we're struggling with. We see many organizations take the controls that are that NIST has assembled as very valuable guidance and apply it as a checklist. I've got these. But who's the one that's making sure that the system is effectively implemented and that they can't bypass that control?
Yeah.
If I could add, it's also part of the mindset challenge or mindset change is changing from the thought of what the system should do to what the system should not allow, right? Thinking not just about use cases and thinking through the threads of what the system should do, but thinking about the threats of how an attacker might abuse or misuse part of the system to their advantage.
I've heard people talk about misuse cases and abuse cases as a way of making that a reality, because you have to be able to communicate to people what could happen that you don't want to happen.
Right.
And in some cases, if you're talking about an airplane, it should not fall out of the sky. Some are very obvious, right? But there's a lot of stuff that is not obvious in terms of what the system should not do, who it should not allow to access, and things like that have to be specified and have to be designed and have to be implemented and verified and certified and all the things that we have in our life cycle before that you can really feel certain that you've at least dealt with that threat vector. That we have lots of them. As you said, Carol, you've got lots of problems to solve. You're going to be busy for a while yet.
Well, part of the mindset too, one of the examples I always use is that there are a lot of organizations and designers and engineers that assume they are working with embedded systems and that these are isolated.
Right.
But in reality, because of the connectivity through all of the different systems, the way software is integrated, updated, all of these pieces, you almost have to prove that you are isolated as opposed to can assume that you are isolated.
Right.
And we don't see that kind of mindset being applied. And so risks are being ignored. And they're very high risks in many cases, especially for critical infrastructure.
Right. Okay, you're going to keep me up again. every once in a while after one of these podcasts, I have a night where I'm like, oh my goodness, here we go again. All right.
It's an opportunity.
It's an opportunity. So you've actually brought up some of the challenges of implementing Secure by Design. There's the education challenge. There's the basic mindset challenge. There's the programmatic challenge of how do we get this in front of people that are in program management roles and taking it seriously. What are some of the other challenges that organizations should be on the lookout for if they are going to take this seriously? And what are some of the strategies for those?
Well, so I think a lot of the big challenges to me all kind of relate to motivation and incentives. So you have there is a constant pressure for software and system developers more so to add new features quickly to the system. There are, for a lot of systems and programs, there's a lot of pressure to focus on short-term benefits and costs as opposed to long-term benefits.
Right.
And so it's more costly, it seems, up front to spend time and effort on security issues of what might happen or preventing what might happen in the future. Another is who is it hurting versus the cost. So users often get hurt more by these issues, not the vendors.
Right.
And so those are three big challenges more related to motivation and incentives, which are really hard to deal with because of the economic and incentive structures that we have in place. Some strategies, I think, part of the model measurement. So what gets measured gets done. So that's kind of a key tenet for a lot of it. Additionally, from the customer perspective or user perspective, when you can, make sure you're adding requirements that, thinking about this from your perspective, what do you need the system to not do or protect your users from? There's also the potential need for regulation, just because some of these problems, the market by itself and the pressure for features and not considering enough security might require regulation and more governance aspects as well. So those are a few. For the training and issues, we already talked about that. So that's one.
Carol?
Getting to the mindset, there is a way of thinking about the problem space that needs to be there. Too frequently, we decompose everything down to the very smallest level because that's the easiest to build, and then put them all back together with the assumption that integration works well. But what we have to think about is we've got a requirement to figure out, do these composition pieces actually create the whole that I'm looking for? There are some structured ways of thinking that we can adopt from the safety area that has also been used in reliability around assurance cases to focus on that claim that we want to be secure by design, and then look at what evidence do we have and start to assemble that. That gives us a structure to start to put the information together as we're moving ahead. It also gives us a way to start to isolate what have we automated and how well is that automation working. And you can potentially farm these pieces out, but somebody has to start owning the big picture. And right now we don't have that ownership. We don't have ownership for supply chain risk management. It's scattered all over the place. We don't have ownership for the system security. It's only belongs to somebody at the tail end that has to issue an authority to operate. And sometimes they're brought in early enough, but most of the time they don't hear about it or see it until it lands on their review table. And then they're ending up being the bad cop and telling them about all the things they haven't done. And it's back to the drawing board because you didn't think about this stuff in advance. Whereas you could have, because it's not like it's secret. It's not.
We're trying to make sure it's not secret.
Yes, trying to give more visibility to this type of thing.
So I wanted to reemphasize one of the aspects that Carol mentioned, which was automation. So earlier I mentioned that automation was one of the aspects of software that was making it more risky for us, but it is a tool that we can use for adding assurance more systematically through the system.
Right.
So adding more automation to the tools of part of our build process, part of our measurement process, so that these aspects and these
Well, you get consistency.
Yeah,
there,
you
which is
get more
important.
consistency to the system.
Well, and
for
they're paid
these types of
attention.
aspects.
I mean, again, and you said a critical thing: controls that can't be bypassed, right, through automation can be. Then you get confidence because they are consistently being applied.
You've got gates
Yeah.
that
Yeah.
check things, or you can have them
Yeah.
if
Yeah.
they're put in that way. But that requires a discipline ahead of time to really automate the right things at the right time.
Right.
And that requires bringing the right expertise in. And again, we're seeing the mindset of, I've done this many, many times over, I'm just doing it again, even though it's new technology,
Right.
new capabilities, new interfaces, new structures. We have to recognize when things have changed enough that we need new mindsets.
Yeah.
And we're at that point now.
Yes, we are. So what we've just recently been talking about, it sort of fall into my mindset as adoption challenges, right? There's a lot of things that are in the way of us transitioning these ideas into practice because of the adoption challenges. What are some other things in terms of transition for organizations that are thinking about this? There's the challenges, but how do you begin this journey? What are the resources, the enablers that are available for people that take this seriously and want to do something about it?
Yes, I think the key is that we're putting in place capabilities that can be integrated with the way systems are already being built.
Okay.
DevSecOps is a popular way of addressing development, and we're looking at tools, improvement of tools, how you run them, where you run them, what they can provide you with, how decisions need to be affected, all kinds of guidance related to that. We've mentioned supply chain, and that is becoming a major attack vector. And so really thinking about, where does the supply chain risk impact you around your system? We've developed the acquisition security framework to look at which pieces of this does engineering own, which pieces does the program level own, how do the suppliers need to be managed, to show how these pieces interconnect. And at least this provides a way of comparing your program to the needs to start to look for gaps.
Okay.
And then we're looking very heavily into threat modeling. And how do we tie those pieces early into systems engineering when they're also using model-based design?
Right.
And show how the pieces should fit together so that we can influence requirements, we can influence the way the pieces are integrated, and then start to influence some of the outcomes that we have to deal with, and really start to highlight these risk issues.
So are we seeing a community building around this? I mean, one of the things that we often see when we have big problems like this is we start to see conferences, we start to see communities of practice. Are we starting to see this for this kind of secure by design and sort of the things that it touches, or are we too soon for that?
There are pockets.
I would say there have been pockets for a long time, and it ebbs and flows with regard to how much the broader community this is a concern. As you mentioned, we just had Director Easterly, come and talk about this as well. So it changes how many people and at what level the attention is with regard to the communities.
I would say the pockets have grown out of the high-risk areas.
Infrastructure.
That's where critical
where it's more
infrastructure,
critical.
the military, the DOD has had a lot of shared information and eyes on the problems. But moving it to the areas where the general developers understand it has been a challenge. And we've got to get there because that's where the supply chain is.
I was going to say, that's the source.
And so, we've had a lot of wraps and close hold on a lot of this knowledge for a long time.
Okay.
And getting it sensitized to a point where it can be just broadly the way we do business is something that has to come out.
I would put it, I'd correct what I said a moment ago, which is where it is more critical. What I should have said is where it is recognized to be more critical.
Fair enough.
And what we need to do is try and help people recognize that their system might be more critical, or there might be more critical aspects and effects of their system and risk and cost than they're currently thinking.
We've had the mindset of just protecting what we call critical assets. And unfortunately, because everything is connected to everything, then even these very insignificant little pieces can become pathways to those critical assets. And since they're no longer isolated because you've got these multi-layers of software that can communicate and do, it's really much more important to look at the whole environment and really understand what's happening, as opposed to focusing on very narrow little pieces.
I don't want to go deep into this, but you just brought to my mind Internet of Things.
It is.
I don't have a refrigerator that gives me contents and everything else, but the fact that it could means it can communicate with me, and that's a pathway.
Yes.
But just think of how much we're relying on the handheld devices that we cart around with us all the time. And even those are connected to our systems and doing major work for us. And we're becoming more and more reliant on them because they're with us all the time.
Right.
It's the path of ease from the user perspective. And businesses are relying on that. Because they no longer have to build that front interface anymore.
Gotcha.
They can leverage what's already there, but what they're leveraging is a very risky platform, and they're not taking that into account when they're looking at the interfaces.
So one of the approaches that we do at the SEI is try to bring a lot of these communities together and the sub-communities, but there's a lot of relationship across them, and have different workshops, have different conferences for these topics. And we've had multiple SecDevOps or DevSecOps conferences and workshops and days and things related to that process. We're planning a secure software by design workshop or conference event to be coming up early in the summer.
Okay.
Right now we have an open call for presentations or presenters. The intent is to bring experts from the outside, not just the Software Engineering Institute, and bring them available to discuss what they think the situation and the community should be focused on, but bring it into an event where people that are not necessarily experts can come and listen to what it is they should be doing and how they should be doing it from these experts in the field.
Okay. And that's the kind of resource we will have in our transcript, because that's what we do.
But we also have some existing training. And so folks that are looking to just get their toe in right now and understand the concepts and issues, there are certificates. I know my team has fielded one in cybersecurity and software assurance. We have books that we've written, blogs and podcasts that touch on lots of different aspects of this. So there's a wealth of exposure that's available. But it requires the people that are in the trenches doing the work to recognize this and raise their heads and expand their perspective.
Part of that, one of the opportunities or our offerings for training is related to, as you mentioned, the blog post about Rust, and for implementation and development activities, we have secure coding standards and guidance for the many systems that cannot just start using Rust, that whether it's because of embedded or legacy code or whatnot, are using C or C++ or even Java, and we have guidance specifically for how to use those languages securely and not inject security vulnerabilities into your code.
Yes, and that's one of the things. I mean, we have a long history of working in that area.
We do.
And I think the fact that we have a long history and that we're still talking about some of these things means that we still have people to reach. when it comes to these kinds of ideas.
And the goal keeps moving further out.
Yeah.
I know I've been working with one of your team members on automated code repair. That's an area that most organizations are uncomfortable with right now. But when the volume of the vulnerabilities is mammoth, we have to look at what can we automate.
Yeah. No, that's true.
And so some of the key ones that are constant problems that are very high risk, we're looking at how do we automate that.
So here we are, one more problem, but we have the beginning of solutions.
Right.
And as always, I mean, almost all of these things in the security arena that I've come to know about as an outsider is about mindset. And that is not something that happens overnight, and we know that. So what are you going to do next to help us to get a better mindset on security? And what are you both working on that I'm going to come bring you back to talk about in 6 months or a year?
Well, we're trying to leverage the pieces we've already put in place. For example, we're taking the acquisition security framework and creating very specific tailored focuses on aspects that are prime in people's minds to get them working with it. Software bill of materials, for example. We're working on creating a tailored version that would focus, if you're going to do software bill of materials, look at these pieces and make sure you don't have gaps and that you've included these. We're also looking at zero trust, which is another aspect of the mindset early on for design.
Right.
And how can we integrate that with what you're doing with supply chain around the acquisition security framework? So those are our key pieces that we're in the middle of. And we're also looking at what processes can we bring to bear to improve the way we're doing assurance cases. That structure has been more of an art than an ongoing capability and process. So we're exploring use of the tools and ways which we can maybe add some pragmatic perspective in terms of creating looking at the data we've got and creating ways to think of what assurance does that give us to help us then identify what are the gaps that we need to be dealing with further on. Okay. So hopefully it will help spur this mindset further.
What about you, Bob? What are you going to be working on?
Well, as Carol mentioned, one of the focuses we've been doing is trying to identify for the development activities and coding, reducing the workload of finding and fixing weaknesses and vulnerabilities. Gotcha. So trying to improve the tools and add automation, possibly with better filtering and automation for prioritization or even automated repairs. And then I'm also working more on with some customers trying to identify more specific approaches for design security. So in the design phases, as you mentioned, selecting your language, even though it might impact you in development, it is a design decision.
It is.
But there's many other aspects about considering encryption, considering different access control approaches that often at the design phase there are problems or defects in those designs. And so we're looking at how to provide guidance for what are the most important, impactful aspects of security in a design phase. And hopefully we'll be able to abstract some of that work from customer work and generalize and provide some general guidance to the community.
I know some people who need that.
Yeah.
Well, and that's the other thing is you cross communities. I mean, that work you're talking about crosses directly into the systems engineering community.
It does.
Some of the other work you're talking about is really more the automated code repair is much more in the implementation, the software engineering, test community. So that's something that I think is notable about the work that we're doing all over CERT, that we are touching not just security professionals, but all the communities that contribute to building systems. And that's really what we're trying to get at, is getting the mindset shifted there, not just in the security professionals.
Well, we need to augment how security professionals think as well, because too frequently they're focused on the final system. They're used to working in the operational environment. But parts of that problem space are owned by engineering and design.
Yeah.
But engineers and designers think differently. They organize their
True.
problems differently. And so when you come to them and say you have to implement these controls, that doesn't match with, well, what are the requirements that I would put in play that would signal that I need that control?
Yeah.
And so we have to educate the security people in terms of how to better communicate the security needs back up into the engineering and design.
Yep.
And I think that's one of the challenging areas to as with the education that most security people don't think about.
Gotcha.
They think of themselves as the policeman, the kind of the last step before bad things happen in the operational world. And that's true, but they have to look at how do they communicate what's needed to get the right behavior.
They can't be the boy putting his finger in the dike, right? You know, that old image. I mean, that can't be the only way that we get this done. It's not going to work.
Right.
Well, it also can't be a game of gotcha. Too frequently pen testing is turning out into that. I mean, most of these systems, if they're poorly designed, it's an easy way of communicating the problem, it's not communicating in a way that you're changing the behavior and the thinking of what needs to be done. And that's where we need to be making our impact.
Yeah, I'd say that it's back to the concept of helping more people recognize that they can be part of the solution for the security issues and helping the security teams recognize how to better collaborate and communicate with them and be part of the team rather than be a separate team that is a gate that is calling out the engineers, but instead, again, working early during early phases in design to be a part of the team and developing those requirements early on for the developers to try and implement those security aspects in the code rather than be called out for not including them after the fact.
So this conversation and the different places that it's gone really highlights the fact that this secure by design is a very broad topic. And so I'm gonna assert that we'll have you back to talk some more about different aspects of this in the future.
It'd be great.
I want to thank you for coming today and for giving people these sort of initial steps to think about and blow their minds open again. And I love it when we get people thinking in different ways. So I want to thank you for that, and I look forward to future conversations. For our audience, we're going to have links in the transcript to all kinds of things we talked about, assurance cases, conferences, secure by design. So look forward to those. And also look forward to seeing this on our YouTube channel if you like the video. We also have this podcast available on Stitcher, SoundCloud, Apple Podcasts, Google. I have to mention all of the different people, but you should be able to find this podcast. But our favorite, of course, is the YouTube channel. So I want to thank all of our viewers today for listening in or viewing us. And again, thank you to Carol and Bob for having this conversation.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.